Okay, so tell us about the connectivity of these two units.
The SPX and DPX have rear-mounted XLR inputs for mic and line, and also an XLR output. This allows you to easily connect to an audio interface or to a patch bay using your existing studio cabling.
I can also see an input connector at the front, so I can plug a microphone straight into the front of the unit.
Yeah, so a microphone input can connect via XLR, or a line input can connect via TRS to the front combi input.
And would I need to disconnect the rear inputs to be able to use the front one?
No, the inputs are selected from the switch on the front. This allows you to leave the unit integrated into your studio setup, all of that rear cabling in place. And then when you need to record quickly, you just plug an XLR in or a line input to the front, press the front button, and you're ready to record straight away.
Now I can also see a DI connection at the front. Does this override the mic and line inputs?
Yes, when a TRS cable is inputted into the DI input, this effectively cuts off the line input and then feeds the high impedance DI through the line amplifier of the unit, benefiting from the discrete audio path.
Okay, let's go over some of these familiar looking front switches. I can see the 48 plus 48 volts and the low Z switch.
Yeah, so the phantom power, this is applied to the microphone inputs only, so it won't go down the line or DI, and that's great for condenser microphones. And the low Z button, this is the impedance selector. So it changes the impedance from the 1.2 kiloohms you get as standard down to 300 ohms, which is ideal for vintage ribbon microphones that typically have a lower impedance setting.
And I guess the lift and the -20 are used for the DI inputs.
The lift switch can be used to remove any ground hum that you might have on a DI signal. And the -20 switch not only reduces the level, but also reduces the impedance from 1 mega ohm down to 10 kiloohms. When you combine this with the stepped gain, this means you're never going to have a signal that's too hot, and you will have enough headroom for any instrument connected.
So let's talk about the gain staging of the 1073. What makes this unit so special?
The 1073 preamp itself is a unique design. It uses two independent preamplifiers, each with 3 transistors that are combined and added at different stages of gain. As the gain is increased, this unique layout gets the most out of each component and allows for very high output at 80 dB of mic gain.
Okay, so talk us through how the preamps interact as gain is applied.
Okay, so the classic red preamp control pot applies gain in 5 dB steps, and it cycles through the different preamplifier gain stages. So starting with the line amp, we go from -20 to +10 of line gain. The next click takes you onto the microphone preamplifier, and this means that there is no need for a mic or line switch. The pot itself selects the correct preamp for the input. As you turn the pot further, and once you get to 55 dB, this is where the second preamplifier is introduced, allowing you to get higher levels of up to 80 dB of mic gain from the unit.
And this is going to give us those classic Neve harmonic overtones.
Yeah, so the character of the 1073, those nice harmonic overtones that make it really famous, are applied over all gain levels, but having this extra preamplifier for the higher gain levels allows you to really drive that hard if you need to.
And in the middle, we have the Neve EQ section.
Yeah, so the 1073 SPX and DPX, like all 1073 modules, have the classic inductor-based EQ. Now, this is the 3-band EQ with a passive high-pass filter included as well. The frequency bands of this EQ were carefully selected to produce musical results across the entire frequency spectrum. This classic inductor-based circuitry delivers more of that Neve quality that producers have loved for the past 5 decades.
Okay, so talk us through the EQ.
Okay, so from left to right, we have the high frequency band. Now this is a fixed frequency at 12 kilohertz and has plus or minus 16 dB of gain. This allows you to decide how much of that glassy top you might need on that instrument. Next, we have the mid band. This is a bell curve, and this is plus or minus 18 dB. We have selectable frequencies from 360 Hz up to 7.2 kilohertz, and optimal frequency points for different vocal ranges at 3.2 and 1.6 kilohertz. The low shelf band is plus or minus 16 dB with selectable frequencies starting in the sub range at 35 Hz all the way up to low mid at 220 Hz. Now, this gives a lot of control over that low bass range.
And at the end, we have the passive high-pass filter.
So the passive high-pass filter is 18 dB per octave and starts from 50 up to 300 Hz. Now, this can be used in conjunction with the EQ to shape the full frequency band, or you can run the EQ flat and just use it for tracking to roll off some bass and unwanted frequencies.
So you mentioned tracking through the unit using the EQ and mic pre. combined to really nail down that sound. Now, can you use the EQ for mixing?
Yeah, so you could effectively leave the line inputs and the line outputs connected to spur I/O on your audio interface and run this as an insert from your DAW. Not only would that go through the EQ, but it would also benefit from the line transformer, the output fader, and the output transformer as well. So you get a lot of that Neve sound on any insert that you applied that way.
I have additional dynamic processing units in my studio that I use for tracking quite regularly. How would I integrate, say, a mono compressor into the 1073 SPX?
So the SPX and DPX include a fully balanced insert, send, and return loop for each channel. So additional processors can be applied into the unit's discrete audio path. We even included a feature so that you can move this insert point pre or post EQ. So it would be after that line transformer, before or after the EQ, and then before the output transformer.
So if I wanted to use a compressor before this EQ, no patching required?
Yes, exactly. You have full control over the signal path. So you can move the EQ before or after that compressor and listen to how it sounds in different points of the chain.
You mentioned the output stage is transformer balanced. Now, can you tell us a little bit about the transformer outputs of the two units here?
Okay, so we're using the Mariner transformer output on the unit. So that gives you that Class A discrete output path. But we also included the output pots on the DPX and SPX. Now, this is effectively a channel fader. So it runs from -infinity all the way to +5.
Oh, just like the fader on a classic Neve console.
Yeah, so this fader pot effectively turns this into a full channel strip and gives you much more control over the final output leaving via the XLR going into your audio interface.
And I can see we have meters here that will show me how much signal is going into my interface.
Yes, so the SPX and DPX have +26 dB of headroom available, and the metering on the front gives you a bit more control over all of your signals. So you can meter the output with the output switch, you can meter the input stage, which is just after the preamp. You can also meter the EQ stage as well.
So if I want to see how much gain I'm adding with my EQ, I can just flip the switch here.
Yeah, so you can use this metering to see how much gain is being added or subtracted at different stages throughout the unit. Also, if you have a hardware insert like a compressor attached, you can see how much gain you're adding on the metering here.
And the OP is the final output level, leaving the unit, so I can see how much signal is going to my audio interface. So if need be, I can also dial that back just to get the optimum level to capture back into my DAW.
Yes, exactly. And the metering will reflect that. So as you move the output fader pot, you can see how much analog level you're sending out of the unit, and then you can level that up onto your DAW meters very easily.